Hello, everyone. Welcome to this session titled Cloudstate Towards Stateful Serverless. I'm Jonas Bonér. I'm the CTO and at Lightbend, and I'm joined by James Roper, Senior Architect at Lightbend. And we will try to give you a little glimpse into what we believe will be the future of the cloud, at least part of the future of the cloud, and through the serverless experience. Let's see. So I just want to start by saying that a lot of people talk about serverless and as the same thing as function as a service, but for me that's not really true. I think function as a service, FaaS in short, is a really good first step. It was really groundbreaking when it came about, and it's really been sort of showing the way, showing what's possible. But it's only the first step on a long journey towards this, nirvana, this amazing cloud experience that we all hope to get to one day. For me, so serverless is really all about an experience for developer, for operations, for deployment that is completely new. In order that one that sort of removes as much as possible from the essence and moving it away to the runtime, to the back end. So you as a developer, or we as developers, can focus on only the essence. And what I would like in my sort of grand vision for the future of the cloud, I would like to build any type of application, build sort of general purpose application, full applications in this new experience. Function as a service is currently sort of tackling one subset of the use cases in a non-trivial application. Sometimes a large portion, sometimes a small portion, but it's just really hard to tackle everything that we need in a non-trivial real world application in just function as a service. So we need something more. So the question is then, what is the missing piece? What is missing here? And I believe that it's state. It's good ways of working with state, solid models for abstracting over state, to essentially having good ways of abstracting over state so the runtime can manage it for us effectively. And so some of the technical requirements that I see that we need in such sort of new way of writing any type of application in this new experience is first support for stateful, long-lived, addressable components that can be virtual as well. It means that you have stable references, stable addresses, but they can still move around, maintaining their data integrity in their state, while the address remains stable. So even if they're relocated, passivated, activated, you can still trust the reference talking to it, and don't need to worry if it fails and it's respawned, etc. We need a wider range of options of tools in the toolbox, so essentially for distributed coordination and communication. PubSub, like we have in functions as a service, is great, but it's only one way of communicating. I believe we also need support for point-to-point, for broadcast, and for things like modeling orchestration of workflows, using things like sagas, process managers, etc. We also need options for managing distributed state reliably at scale, and not just having one size fits all. Not saying that everything needs to be strongly consistent or everything is eventually consistent, but having options ranging from strong to eventual through causal consistency. So you can fit serve the weakest model that gets the job done. Because if you add layers of safety, of guarantees on top that you actually don't need, that's wasteful. So you actually want the minimum guarantees that gets the job done, that liberates the runtime to do even more things in terms of scale and availability. Okay. We also want intelligent, adaptive placement of stateful functions. Things like sharding, having a physical co-location of state and processing, as well as sticky routing. These are very important things in order to manage data at scale, performantly at scale. function as a service is really good at abstracting over communication. So you have your user function and you have your sort of message in. You don't need to worry how it ended up there. It just it sort of ends up on your mailbox or a queue to your function and passed into you for processing. And the same thing, message out. You only emit the event, and you don't need to worry about where it will end up, who's going to pick it up, etc., and the mechanics for doing so. You have well-defined interfaces for message in and message out, or event in and event out. And you just work towards those. But the problem is that sometimes you need to manage state. But if you talk to the database directly, you're sort of moving a lot of these operational concerns, the things that function as a service or serverless, rather I would say, is meant to manage for you. It's supposed to abstract away all these hard things, but by managing, so data access and usage from within your function yourself, you sort of eliminates that option from the table, essentially. And the problem is that now the function, is sort of a black box to the runtime. If the function manages state it's himself, the function can't sort of see in and understand what's really going on here. And it's a fact that sort of unconstrained database access, which sounds like a good thing. I mean, more power is good, right? But it's actually not always the case, because it makes it really hard for the runtime to automate operations on behalf of the function. So it's really hard to understand sort of the intention of each access. For example, is the operation a read or is it a write? Can it be cached? Can consistency be relaxed, or is strong consistency always needed? Can operations proceed during partitions and failures, etc. Right? If the runtime understands these things, it can make intelligent sort of decisions more effectively. And also, see broadly across all of your entities and making things, collectively optimized. And as Timothy Keller, once said, that freedom is not so much the absence of restrictions as finding the right restrictions, the liberating restrictions. So the question is then, what are those liberating restrictions? And as I said, the function service is really good at abstracting over communication. So you have message in and message out, as we just talked about. The question when we asked ourselves at Lightbend was, is it possible to abstract over state in the same way that function as a service abstracts over communication? So instead of just message in and message out, you also have state in and state out. So it's sort of an inversion of control here. Instead of the function manages himself, the state gets passed to him, and he can just emit state. And all the sort of hard things around managing that, how the state is handled in the backend, is sort of delegated now to the runtime in a true serverless fashion. The problem is that CRUD doesn't always fit this model, but we need new models and new ways of thinking about the state. I'll get to that just in a second. So that was sort of the premise when we started Cloudstate, trying to answer the question: can we abstract over state in this way, and can we provide a stateful addition to function as a service that's great for stateless workloads? So the joint thing can give us the platform we need for general purpose applications. So what is Cloudstate? You can find out more after this talk if you go to cloudstate.io. But the overview is that, first, it's open source, fully Apache 2. It's available on GitHub. You can just go and check it out and mess around with the code and contribute, ideally, if you like. The sort of short one sentence is really that it's distributed state management for the cloud in a serverless experience, as I talked about. And it's really two things. First, it's a reference implementation, but it's also standards or a protocol and a specification. So this is possible to create more than one implementation if people feel inclined. But the essence is that it lets you focus on your business logic, your data model, and your workflow. That's it, essentially, and how to configure declaratively these things. It's sort of leveraging Akka to do a lot of the heavy lifting with cluster sharding and persistence and things like this across the nodes, the Kubernetes pods and things like that. All the hard things around state, both long-term durable state as well as like more short-term ephemeral state, coordination type of state, scratch data, and these things are managed by Akka. It leverages gRPC as a protocol, between the backend and the client. I'll get to that just in a second. It leverages Canadian Kubernetes and also runs on GraalVM, which allows us to compile it down to native. Since Akka runs on the JVM, it's very important to minimize the memory overhead and the startup times. And GraalVM really helps us with that. So it's really polyglot. And here's where we sort of leverage gRPC. The gRPC sits right in between. It's a protocol how clients sort of make use of this sort of distributed state management. And essentially any language that has support for gRPC can be supported by Cloudstate, because essentially all these clients are gRPC clients. And we currently have support for JavaScript, TypeScript, Java, Go, Dart, Python, .NET, Rust, Swift, and Scala. Not all of them are complete, but a lot of them are being worked by the community as we speak. So it's really exciting to see the community pick these up and sort of cranking these client libraries out. It also supports like polystate. As I said, CRUD's not always the best answer to sort of the serverless story. But other models that I think fits better is that we support now in Cloudstate is event sourcing. I want the time to go through what that is really and how it works. But event sourcing is really, really cool. CRDTs, like, it's essentially conflict-free replicated data types. It allows you to share state freely in the cluster without worrying about race conditions and inconsistent data. It's eventually consistent, while event sourcing is strongly consistent. So it gives you two models for that. We also have key value store. And it supports that across a wide range of databases, SQL, NoSQL, NewSQL, and also in-memory replication. So if we're just going to end by sort of zooming out a little bit, what it looks like, is that you can see on the right-hand side that that we can write functions or these entities or functions, stateful functions in any language. Like we can have, for example, a Python type of shopping cart. We can do Java implementation of an order, and we can have a JavaScript function implementing the inventory in this simple example. But the interesting thing is that for all the clients, web clients, IoT clients, they communicate over gRPC to these entities, but they do that through the Cloudstate proxy. And the Cloudstate proxy is sort of managing all the data on behalf of all these entities. It sort of populates them as needed, as they are requested, So all of these entities are always fully hot. They always have the latest data available. They're sort of truly, really endpoints, and the database sits in front of it. Again, having this inversion of control, where each entity is just, sort of sent the things he needs at each moment, so to speak. And the Cloudstate proxy looks across all of these entities and optimizes the data storage for all of these state models across all the entities you have. So that's all I had as an intro. So now James is going to give us a little demo here and go into more details about how things look and how you can get started with Cloudstate.
Thanks, Jonas. Now I'm going to be creating a demo application so you can see Cloudstate in action. This demo application is going to be a Q&A app. It's going to allow participants of a conference to ask questions and vote on those questions for a speaker to answer. Unfortunately, I don't think we'll be able to use this for this session because I think the organisers of KubeCon already have a Q&A application in place, but maybe next KubeCon they can use this. So, to prepare for this presentation, I've already got a few things in place. I'm going to use JavaScript for this. Cloudstate supports a range of different languages, but JavaScript is a language that many people know. So I've set up a package JSON. I've got a Docker file so that I can build this and deploy it. And the first important thing that we're going to look at is the protobuf file for the Q&A service. So here's our gRPC service here, service Q&A. There are two RPC calls, ask and watch. So ask allows asking a question, and it's also used to vote on a question. So you send an ask request with the same question that's already there, that will register as a vote for that question. Watch allows us to get the current questions and votes, and will also push new messages whenever there's new votes, so that we can update the display in real time to see the voting in real time. You may not have seen this before in a gRPC interface. These are HTTP transcoding annotations. This will allow us to consume the service as a REST interface, and Cloudstate for the watch actually has support for server-sent events, and and so the watch will be done using server-sent events. So another thing to look at, both of these requests, ask request and watch request, have a field on them called presentation, and that field has an annotation on it saying what the entity key is. So a single Cloudstate service may serve many entities, each with a unique key, and this is how Cloudstate knows when it proxies the calls going to the service what the key of the entity that it's currently being served is, so that it can enrich those calls with the current state and be able to provide the user function with everything it needs to be able to serve the calls. So we have that on both ask request and watch request. And you can see the questions that we return from the watch request. It's a stream of questions, is just a map of questions to the count of people that have voted for that question. So let's get on to implementing it. So I'm going to start by requiring the Cloudstate module, and I'm going to create a new entity. In this, I pass the path to this Q&A proto file, as well as the fully qualified name of the service that this entity is going to implement. Now, to implement this service, I'm using a CRDT. CRDT stands for Conflict-Free Replicated Data Type. And what CRDTs allow is for state to be shared between many nodes, so we can deploy this to be many nodes, and those many nodes can read and update that state independently with no coordination. And they're guaranteed to all converge on the same state eventually. So we'll see this a bit more as we go through. One other bit of setup, I'm going to set a default value for this entity. So when a request comes in for an entity that hasn't yet had a state created, this callback is used to say which CRDT we're going to use. And in this case, we're using something called an observe removed map, which is a map that can be modified, things added and things removed from multiple nodes at a time, and is guaranteed to converge on a single state. So let's get right into implementing our service. We'll implement the ask call. So here's our function, ask. We take the request, that's the ask request with the question in it, and we also take a context variable. And the context is what holds the state. So I can then check, does the state have the question that is being asked? If it doesn't have the question that's being asked, I will set it to a new gcounter. Now gcounter is another CRDT. It's a counter. Gcounters, it stands for grow only counter. They're great because you can have 100 nodes incrementing these counters all simultaneously with no coordination, and you're guaranteed that every single increment that you'll do will be counted. Nothing's going to override each other. There's no coordination, no locks. Gcounters are a really great CRDT, and we're going to use that to count votes. The final thing that we'll do, so after we've ensured that for that question we have a gcounter set in the map, we'll increment the counter for that question by 1. And finally, we just return empty. So that's the ask call done. The next thing that we want to implement is the watch call. So similar to ask, we take a request and a context parameter. We're not going to actually use the request parameter. And one thing I'm going to do here is create a helper function to copy the questions from the CRDT map into a straight JSON object. So the keys of this object are going to be the questions themselves, and the values will be the current counter, the current value of the counter. So we'll iterate through the current OR map, and for each counter on question, we will then update that counter and finally return the questions. So now we can use that method to get the questions. And I will then return those questions. And so when this watch call is first invoked, those questions will be returned. But we also want to push a new value for the questions every time the state is updated. And so to do that, we're going to register our onState change callback. An onState change allows us to take the state and return a new message that should be sent to the client each time. Now we could just copy the questions from the current state again and return them, but this is inefficient because it means we're sending every question with its votes each time, even if it hasn't changed since last time. So I'm going to write another helper function here that's going to update the questions map with the new value for with anything that's changed, as well as produce an updated JSON object with just the changed values. So similar to before, I iterate through the map, and if the question in the map doesn't exist on our existing questions, or if the counter value is different, then I'll update both the questions map as well as the updated map that we're keeping a track of, and finally return that. And now I can use that map, that helper function here to both update my questions map that I'm keeping a track of, as well as return the updated, get the updated field. And so then we'll just quickly check if there are any fields that have updated. So if the number of keys in there is greater than 0, then we'll return the updated questions. And now we're almost finished. We just register those command handlers on the entity. So the ask function will be used to handle the ask command. This is from here, that will handle that, and watch method will handle the watch gRPC method. And finally, we'll start the entity. And now I've implemented my Q&A stateless function. So let's now build that. So I'm going to run npm run docker build push. So this is a helper function that I created before. And while that's running, I'm going to quickly show you this UI that I created. So this is a separate deployment. This obviously is not part of Cloudstate, but it's going to use that stateful service that we just created. So it will let us select a presentation from here and be able to ask questions on it. So I've now built the Docker image. Let's take a look at the descriptor for deploying a stateful service. As you can see, it's a Kubernetes descriptor, kind stateful service, and we have the user function container here with the image. That's the image that we just built and published. So let's now deploy that. Kube control apply -f quanda.yaml. And just for fun, I'm going to scale that up manually to 6 replicas. Obviously, I've got no load on it at the moment, so it's not going to auto scale up, so I'll manually scale it up to 6 replicas. If we do kube control get pods, we can see some of them are already running and they're starting, and before long they should all be running and in a cluster. Now, one of the reasons why I've scaled up here is because I want to demonstrate that this is truly distributed state. If I'd scale this, just run one node, then it wouldn't be that interesting because it's very easy to get state consistent on one node, but because it's running on 6 nodes, and because anything can, when a request comes in, it could go to any of those nodes. If those nodes aren't sharing their state and the CRDTs aren't working, then this demo won't work. So it's all running now. Let's go to a presentation, and I'm going to ask a question, and it appears there. There's a little bit of a delay there. That's because I haven't done anything to try and update the state locally in the client. When I ask a question, it actually relies on the update of the CRDT, which then will get gossiped to the other nodes and then get pushed down. So can I ask another question? And that worked. Why don't we try from another browser? Does it work across browsers? And we can see, yes, indeed it does. If I vote in this one, I should see that go up. So we can see voting works. We can vote all over the place and just click vote, and all these things should eventually converge on the same state as all the nodes. And I don't know actually which nodes these are connecting to. It's using a load balancer that would randomize it, so they're probably not connecting to all the same nodes, but what we can see here is our demo is working. Now you can visit this app. This presentation is pre-recorded. It would have been kind of cool if you could all visit this now, and we could see everyone updating it. But if you in my presentation, but if you go now, you can see with the other participants in this presentation voting and have a play with it. So that's csq&a.app. So that's the end of the demo. Thanks, Jonas.
Thanks a lot, James. That was a great demo. Now I think we have time for some questions. So if you have any, fire away.